Okay, so about 10 months ago, the North American Linear Collider group had its workshop in Johns Hopkins. In the time since then, a whole lot has happened, and clearly we can see that it has happened since there are many more of you here for this workshop than were there at that one. The charge that was given at Johns Hopkins is indicative of where we were at that time. It said that the chief priority for the group of people who were advocating a linear collider was to reach some kind of a consensus within the American high-energy physics groups as to whether this was or was not the direction that we wanted to go. Clearly, we've gone a fair distance since then, and this workshop, as Mark suggested, is now to try to understand what are the next steps, what are the things that are really going to occupy our attention as we've passed certain milestones. The milestones that we've had since the time of that workshop are several. 2 days later, Tesla unveiled its proposal and delivered it to the German Science Council. It is being considered. I think everybody understands the basic outline, and we'll hear more about it shortly. In preparation for Snowmass, and many of you in this room worked very hard to produce a book. It finally turned out to be an uncomfortable 400 pages of material on the physics, on detectors, on issues for special facilities, and so forth. A great deal of work, and I think it was useful in setting the tone and the terrain for Snowmass. Then at Snowmass, the physics groups worked very hard, and at the end of the 3 weeks, as you know, the physics groups came together and jointly made a recommendation that the next and most high priority project for the field was to build a linear collider. The following month, the European ECFA working group came out with a proposal which also made that same recommendation. These various proposals, I'm not going to read them. They differ slightly. You see a little bit of spin and politics in the numbers that are associated. So the Europeans say up to at least 400 GeV. In September, the Asian ACFA group issued its statement, again proposing a linear collider be built initially in the 250 to 500 GeV range, but upgradable to more than 1 TeV. In October, the HEPAP subpanel draft statement came out, and it had recommendations. First, that the highest priority for the American community is to build a linear collider somewhere, that the U.S. should make a proposal to site it in this country, and that there should be a steering committee formed to oversee all activities related to the linear collider. So what we have had then is all three regions clearly and ringingly endorsing the next priority for the field to be the linear collider and to pledge to work together to try to achieve it. These workshops will continue in Europe in April in Saint Malo, in Tokyo in July. At a time, sometime in the May-June framework, we expect to have the successor to this workshop someplace in the U.S. The venue is not yet set. And then in August, the worldwide workshop, the successor to one that was held in October of 2000 in Fermilab, will be held on an island in South Korea. So clearly the playing field has changed. We have a strong statement of priority from across the field and across the world. It certainly does not mean that everybody in our field intends to pin their own physics futures to a linear collider. It is, after all, one of several interesting questions that we all want to understand. These other proposals are still on the table, and some of them will probably proceed on a similar timescale, if not before. And it's simply something that we need to remember, that although the linear collider is, in many of our views, in my view, attacks the question that has the best chance of making fundamental progress, that there in the near future, there are other questions, and those need to have some attention as well. The physics case for the linear collider, we've worked rather hard on that over the last several years, and it seems to me that at this point, that case is quite clear for an initial 500 GeV class machine, upgradable in the future. There will be talks on the various aspects of the physics later today, and we'll hear what that case is. But the case that has developed is quite simple to state. First of all, we know there has to be something that plays the role of the Higgs boson, and that it should be accessible at a 500 GeV linear collider, and we need the linear collider in order to understand what it is, because the LHC will not tell us all of those things. Secondly, we believe that there is a very high probability for there being new physics at the TeV scale, something beyond the standard model. We don't know what it is, but we think that for all of the cases that we have examined so far, there are important, crucial, and often unique capabilities from the linear collider in order to unravel it. In the case of supersymmetry, LHC will discover it, but it will not really delineate all of the things about supersymmetry that tell us how it works, how it is broken, and so forth. In the case of strong coupling or extra dimensions, the LHC and linear collider complementarity is particularly well at view. The two programs do things in a way that complements what the other is doing. There are clearly other important physics topics that will go on at the linear collider, but I think the case, the simple-minded case, is really understand electroweak symmetry breaking. There is a clear prospect that fundamental progress will be made in that sector. Now, clearly there are remaining physics questions that need to be studied, need to be understood, but it seems to me that the main outlines are in reasonable view at this point. So, although I've listed here a few of the things that struck me that are topics where physics studies continue to be needed. For example, in supersymmetry, it has never been quite clear how one disentangles, in the case of backgrounds that involve supersymmetry, two supersymmetric processes, how well can you really unscramble what the particles are, what their quantum numbers are, what the branching ratios, what the cross-sections, and all of these mixings that characterize the supersymmetric world. So I think there's a good deal of work to be done there. The extra dimensions world is sufficiently new that we're still trying to understand the phenomenology of it. It's once again a tree of many, many possibilities, and we have to begin to follow that tree. So there are clearly physics studies that remain for us. And they should continue, and in part because they help to educate all of us as to what the real power of the linear collider will be. I mean, we learn by doing, and we need to continue to do those things. There's one question which it seems to me that we don't really have as clearly articulated an answer to as we will need, and that is, why should the linear collider at 500 GeV be started before the LHC has produced data? Now, this is a question that comes up over and over again. It is a sufficiently simple question that I think we can count on the politicians and the bureaucrats thinking of the question and asking it of us, and we had better have an answer that is compelling to address that. So, in a sense, I guess I would like to propose a competition, or to imagine there be one, that we start to write down how do we make that case in a way that is approachable by someone in the who's not in our field. Why do we need the linear collider, and why should we start now and make that sufficiently compelling that we can tell our congressman or staffer or OMB person why this is the case? And bear in mind, of course, that the recent news has been full, at least in Europe, about how the Higgs now doesn't exist, so we've been chasing the wrong tail for the last decade or so. Detector issues. Here I think that unlike the physics case, we really need a great deal more effort. There's been more attention given to detector issues in Europe and Japan, I think, than there has been to the R&D program in this country. Rolf Hoyer will give a talk on the last day of the meeting on issues that are on the table for detector R&D. Many would say that the linear collider detectors are not going to be as complex, perhaps, as the LHC detectors, and in some ways that is true. And therefore, we can sort of take what we've learned from the R&D program for the SSC and the LHC and use those ideas. On the other hand, the linear collider is a quite different environment, and there are different issues, and there are different needs. And broadly, the two needs that I think are the dominant ones. One is that we need as good a ability to identify partons, dominantly through vertex detectors, as we can possibly get. The payoff for being able to tell whether we've got B, C, tau, so forth and so on is enormous. The second area where there is clearly a premium is to get the best energy resolution for jets as can possibly be obtained, not only to be able to distinguish the W and Z hadronic decays, but also to investigate the Higgs self-couplings and the Higgs potential, and so forth. How well can one do? And the environment being more benign in the linear collider means that you can make different compromises, different optimizations than at a hadron collider. And finally, the detector integration techniques are quite different. The event rates are low. One can make quite different choices than one would do at the hadron machines. So if we're going to capitalize on the new detector ideas, if we're going to get those ideas and understand them, now is the time to be working on that, because we're going to go through a period of some number of years trying to get to the political approval, and during that time is the ideal time to work out these issues related to detector R&D. So the needs as I see them, first of all, we do need more money to support the detector R&D program in this country. Clearly, all regions are strapped for cash in supporting this kind of activity, and it seems to me that we will gain enormously by banding together and working on these detector R&D projects collaboratively across the regions. And in any case, since we all know that the final operation of the linear collider is going to be a worldwide collaboration, the more we do now to enhance those collaborations, the better off we are. Okay, there are some other issues, and they have concerned us in the past, and they will continue. I don't want to dwell on them particularly here, but we will discuss them to some extent during this meeting. There are important things where the accelerator physicists and the experimental community need to work together very closely. There are pieces of the physics program that demand a superb measurement of the energy of the machine. We have to understand how to do that, and it is not entirely clear. The question of polarization. The electrons will be polarized. There are schemes for doing positron polarization. We need to understand what the effective polarization is to a very high precision for some of the physics topics, and we're not out of the woods yet in trying to understand how best to do that. The IR strategy. Well, the different machine proposals that are on the table now differ somewhat. I think that's mainly historical. But we need to come to grips with what is the optimum intersection region deployment. The American proposal has a high and a low energy IR. The Tesla proposal has one with the possibility of adding a second, but co-equal. What's the physics and the political rationale for having two major detectors at this machine? These are questions that will concern us. And finally, this project will be something that is much more powerful and much more palatable and more ecumenical if we can have a degree of outreach so that the facilities that are built are usable by other communities. And I remind you that there are many different aspects to the many different components of the linear collider. We have electron-positron sources, we have damping rings, we have spent beams, we have a whole long line of seismically controlled fixtures. All of these things can be made useful to other communities, and I think we need to begin to think about how to make this outreach for the use of these facilities by other branches of science. Okay, so clearly the topic that is going to engage us more and more as we go on from these consensus about what we want to do is the question of how are we going to do it. And it's clear to all of us that we should surely never underestimate the difficulty in getting this machine. It is technically challenging, as we know, and although on paper people say, yes, we understand now how to build the linear collider, it is clear that there remain very difficult challenges in achieving those. And we'll have the four talks immediately following that try to outline some of that, and then on the last day talks about future accelerator R&D. These are critical issues, and the experimental community needs to participate in trying to solve them. The cost is going to be high, we know that, and it is higher than we expect that any single region can afford. We therefore say that it is going to be international and will be international from the start. And we also have really not any very good idea yet how to bring that about. So that clearly is a challenge that we have to address. Our governments are preoccupied in many other ways. I think it's safe to say that most politicians don't get up in the morning and say, what can I do for high energy physics today? They have things that they feel are important and perhaps even more important, and that's going to be something that we have to combat. And finally, there's the competition with other large projects in science and in applied science. And I should remind you that the bureaucrats actually don't distinguish very well between a linear collider, a space probe thing, some laser fusion, whatever. For them, if it's big and it spends money and it's located somewhere that they recognize on a map, that's reasonably it. Our colleagues in the other branches, of course, can distinguish, as we can, which thing is for what kind of science. And the extent to which we will be successful will rest to some considerable extent on the way in which we make an outreach to our colleagues in other scientific disciplines. Okay, so there are several steps that I see. First of all, we will clearly need to have a discipline in getting realistic costs from the beginning, not only for the project, but for the R&D, for the infrastructure, the stuff that goes along with any of these large projects nowadays, the manpower, the escalation, all of these things. We know we were burned severely with the SSC when that control of the costs was not adequately done. And we are now seeing difficulties with the LHC as the cost overruns there are occurring. Our political capital is certainly damaged by those activities, and we have to guard against it from the beginning in the linear collider. We're going to need to choose the accelerator technology. Is it warm or is it superconducting RF? The low panel will help define some of the trade-offs, and we expect to report from that committee later in this year, and a description of the process during this meeting. That will clearly be useful. It's not going to yield a choice, but it is going to try to make a comparative statement of the trade-offs and the risks and so forth. It seems to me that by the time we come to really making a decision on starting a linear collider project, it's going to be very difficult to do that unless we know what it is that we're going to build. That is to say, the choice of the technology is going to have to somehow get made by the time we come to this real final approval process. It's going to be painful for us, for the high energy physics community, to make that choice, because it's quite likely that the competing machines have sufficiently similar capabilities, costs, and so forth, that there won't be a clear distinguishing. We're going to have to make a move to do that and to establish a process by which we can try to do it. And that's the next point on what many of us have been saying we now need, and that is to begin to establish a process by which we can make these decisions. How are we going to define the funding arrangements? The host country share, the other participant nation shares. How are we going to structure the decision for the site? What is the organizational structure? There's a nice paper on the web page for this meeting contributed from George Trilling, pointing out some of these things. One of them is it a structure that is only for the linear collider, or does it envision encompassing projects that follow on further in the future? How do we retain the health of the accelerator and particle physics communities across the world when the linear collider is built, obviously, in only one place? So we need to begin to address that process and to write it down so that we can then begin to follow it and take the decisions that are addressed. And finally, to articulate the rationale for the linear collider to the governments. This will not be the last project that we propose. We sometimes make the mistake of saying this is the be-all and end-all. Give us this and we'll be happy for the rest of our lives. And you know that's not going to be true. It has to be sold on the fundamental scientific worth. There is no other way to justify a project of this size or this scope. Spin-offs are nice, but they don't justify projects. The HEPAP subpanel was sort of nice. It developed this mantra, sort of like saying, matter, energy, space, and time. That kind of salesmanship may be repellent, but probably it's the sort of thing that we need to learn to do. Okay, so that's it. The conclusion, I think, is that we have made real progress in the last year. We've probably done the easier part, and the hard parts remain. I suppose it is nice that the University of Chicago has invited us to this lovely center, testimony to the ability to market and to be salesmen. I invite all of us to wander around and pick up the vibes from this building while we're here.